just yesterday here a little bit about oxidation numbers. Okay, so we talked about the oxidation state. Remember, these values can be positives or negatives. They can be integers. They can be fractions. So today you're going to see that. Today they are part of a fraction. You're going to see that today. Remember, the elements are zeros, oxidation numbers. H's are always a 1 plus, oxygens are 2 minus, and any charge, like for example sodium ion, sodium plus is a 1 plus. Okay. We did this yesterday, and like I said, if you haven't done this yet, maybe go back and look at the YouTube thing there, the Google thing there, or whatever it's called, and look at that and check that out basically for that. Okay. 2 exceptions, don't forget metal hydrides. Metal hydrides, H is acting as a 1 minus, and peroxides, the oxygen is a 1 minus. Okay, so those are 2 exceptions you want to know. We talked a little bit about how you're going to assign these. Well, always start with hydrogens or oxygens, right? Start with those first. Hydrogens, oxygens, 1 plus, 2 minus for oxygen. Then assign the other numbers. If there is no hydrogens or oxygens, yesterday we said, remember, go with the more electronegative atom, give it its normal charge, so bromine, or in this case, or bromide, depending on what you want to deal with that there, but bromine is the more electronegative atom, so give it its -1 charge, okay, that you have in that group there, and therefore this would be, of course, to neutralize that out for positive, yes? Okay, so four -1s and then a 4 positive. And we did the rest of these examples here, so I encourage you to check those out. We talked a little bit about identifying redox reactions, okay? Obviously in this case here, this oxidation number is going from 0 to a 2 plus, so we know that that is being oxidized because this is important for today. You're going from a, well, 0 to 2 plus, you're going up in numbers. So you're going up in numbers, or up in a, you know, from the, if you think about the number line, you're going 0 to 2 plus, that's oxidation. And of course, that is your reducing agent, therefore, yes? Because it's being oxidized. And vice versa here, if it's being reduced, it's going down in numbers, just like reduced sounds. You're going from a 0 to a 1 minus in this case, okay? So it is going down in numbers, you're being reduced. This is your oxidizing agent, okay, reduction. So oxidizing agent, okay? We talked about that there, that my graph messed up, of course. We talked about how to identify a redox equation. Are they all redox equations that we're going to do? And the answer is no. They might give you a list of 4, and they might ask you which one of these is not, or which one is the redox reaction or a redox reaction example of. They're not all, okay? So you're going to write them out. You're going to use oxidation numbers, which we're going to do today, and you're going to see if they go up in charge or down in oxidation charges or states. And if that's the case, that is a redox reaction. If it doesn't happen, it's not. Okay? So keep that in mind. All right? We wrote out methane yesterday, so once again, if you weren't here, check it out on the web there or whatever. We assigned some oxidation numbers to this here, which we're going to do again today, and I'm going to get you to do a little practice with that in a bit, so not too worried about that. And then we did not get to this part here. This is the last kind of 2 things here. Disproportionation, we've already talked about. Okay, we did a whole lesson on that. Well, it wasn't yesterday, it was the day before, so I guess Wednesday was the whole lesson on disproportionation. Obviously, we know that the reactant is both losing electrons and also the one that's gaining the electrons, okay, as you go from the reactants to the products here. So it will show that one type of atom is changing its oxidation state, or oxidation number. Therefore, the same reactant, of course, acts as the OA and RA, and you guys know that already. It's the same reactant for both, right? So when you get an example like this here, we're going to assign some oxidation numbers, so let's go ahead and do that right now. Maybe I'll give you guys a little bit of time here. You guys do that, and then we'll go over that real quick, and we'll move on. Hopefully we're done there. Hydrogen's always a 1 plus, of course. Well, hydrogen is a 1 plus. It's got the H plus, of course, there. This is a 2 minus for oxygen. This is a 1 plus for hydrogen. So don't forget, you have to, that's per atom, and that's what we're going to talk about again today. That's per atom. So look, you got 6 minus and a 1 positive is 5 minus. So this one here has to be, that's 5 minus. This one has to be 2 positive, right? 4 positive, because overall that's a -1 charge, yes? So if you add that up, hopefully that works out. 6 minus, 5 minus, 4 positive, that's a 1 minus. So that should be good. S8, elements by itself, 0. 2 minus, oh, water is always nice. Nice. 2 minus, 1 plus, of course. 0 altogether. And then over here we got a 2 minus and a 1 plus. And let's see, that's 8 minus for oxygen. And a 1 plus, that's 7 minus. And so therefore this sulfur has to be a what? 6 plus? Yes? Huh? But if there's a negative at the end. 8 minus, 7 minus, and 6 plus. Yeah. Right? Good? Yes? No? Last one. 8 minus, 7 minus. So I need 7 minus. I need 6 positives to give me a 1 minus. Yeah? Okay. All right. So that's disproportionation. Oh, that's not actually disproportionation yet. I'll show you. But that is, of course, assigning oxidation numbers. Look, if you look here, what is going on? What is changing? Well, I see, hey, look, sulfur looks like it's going there, right? So sulfur there has a 2 plus oxidation number. Sulfur there has a 0 oxidation number. I would say this is being oxidized or reduced. Reduced. So therefore, this is being reduced. So that's your oxidizing agent. Yes? This is disproportionation. So guess what? You already know that the OA is the same as the RA. So I'll give you a little hint. This is also the RA because it's disproportionation. This sulfur is going from a 2 plus to a 6 plus. So that is being oxidized, right? And therefore that is your reducing agent. Okay? And the only difference, what we're going to do today is we're going to count up how many electrons are actually being transferred, et cetera, and balance those out. That's what we're going to do today. Okay? So that's disproportionation. Good? Yes? Questions, anyone? Okay. Now, hopefully, let's pay attention today because this may blow your mind. Maybe not. But anyway, so we're going to do some balancing with redox reactions with oxidation numbers. We've given you so far, after today, you will have 3 different ways of balancing redox reactions. The first one, data booklet. I gave you back a quiz on that today. Yes? Write out the reduction half-reaction, write out the oxidation half-reaction, balance electrons, times 2 times 5, remember, from earlier today? Times 2 times 5. Balance out electrons, write out the redox reaction. That's 1. 2, under acidic conditions, which is what you did today, / basic, okay, which is hopefully what you did today. Let's hope. So that's the second way. The third way is oxidation numbers. And the answer is, can I use any of those 3 ways? And my answer to you is yes, maybe, possibly, but you need to know all 3. Okay? Because it really depends on the question, depends on which way is probably going to work the best for you. Okay? There's going to be specific questions about oxidation numbers. There's going to be specific questions about probably ones that you can look up in your data booklet. And there's going to be specific questions about under acidic or basic conditions. Okay? And most of the time, I'm not going to lie to you, that most of the time it's going to be acidic. Okay? In fact, it's going to be acidic probably because they usually don't ask you basic. So I'm not going to lie to you. That doesn't mean I won't ask you basic. All right? So this is your third way here. Okay? Now, they're going to give you some rules here, okay, or some steps here to follow kind of thing. But, and really, we're just going to have to do this, and you're going to have to see this. Assign oxidation numbers, that should be pretty obvious. Since we're going to balance with oxidation numbers, I hope you go through and assign some oxidation numbers, because that's going to tell you which one is the OA and which one is the RA. Okay? So you're going to identify those by assigning oxidation numbers. So that's step 1. Assign oxidation numbers, identify the OA, the RA. You're going to determine the number of electrons gained by the OA or lost by the RA, whichever you wish to do. Well, you got to do both, okay? Whichever you want to do first, I guess, is my thing there. So whatever you're going to do, you need to balance out those electrons, right? You know, when we did our when we went over our quiz today, I said, okay, we got to balance out the electrons, right? Times 2 times 5. That's exactly what you're doing here. You're just not writing out half reactions for these. But I'm still thinking in my head, hey, if I'm losing 2 here and I'm gaining 5 here, what's the lowest common multiple of 2 and 5? It's 10. So I got to make sure that they balance out, right? It's the same thing. This is exactly what we're going to do. And when I write it down, I'm going to be like, this is what I'm talking about, okay? Once you've done that, okay, by applying the simplest whole number coefficients to the OA and RA, you're going to balance the other atoms by basically, and charges and all that other stuff, by what we call inspection. So basically, you're going to look and you're going to start balancing stuff out, okay? The important part with these questions is we need to focus on, really, yes, we do need to focus on reactants versus products, but we're really focused on the 2 reactants, the RA and the OA. And those are the 2 that we need to balance out, okay? So here we go. I want you guys to start, of course, step 1, what do you think? Oxidation numbers, because that's how we're going to balance these bad boys, yeah? So let's do that. Let's do some oxidation numbers. I'm going to rewrite mine because mine's too big there. So go ahead. Okay, so we're going to balance this to chemical equation right here by using oxidation numbers, okay? And this is kind of what you need to do. Well, first of all, we need to start by putting some oxidation numbers on these. Let's see. So what is that? 5 plus 6 plus 4 plus 2 of them. So 2 minus, yeah? Double check with me here, please, because I sometimes, huh? So let's see here. This? No. It's an ion. Is it not? See, 3 plus, yeah. Oh yeah, no. Did you check your homework? Where? Like three pages back. You wrote it down wrong. Yeah. I'll prove it to you. I have YouTube. 4 plus, that's, what is that? Let's see here. 4 plus, that's 4 minus. So that's got to be a 0 and a 0, yeah? And then this is a 2 minus and 1 plus. Okay. There you go. Good so far? Yeah? Okay. So, here we go. Now, focus. All right? Because otherwise, will happen. So, we have to find, okay, and this isn't anything new to you. We're going to find the one that goes, obviously, down in oxidation numbers. We're going to find one that goes, hopefully, up. And hopefully we can find those, because otherwise, well, that's bad. Because if one's going down, one's got to go up, yeah? Okay. So we look at probably here, look, chromium 6 plus. Oh, but chromium's a 3 plus here. Okay. So I say, how does chromium, remember, These oxidation numbers are for each atom of chromium, yes? Not for all of chromium there. That's what we're doing here. We're doing each atom of chromium has what oxidation number. That's all we've been doing lately, right? That's why we divided it by 2 there, of course, to get 6 plus for each one. Yes? So each chromium goes from a 6 plus to a 3 plus. Oxidizing agent or reducing agent? Oxidizing agent is correct because it is being reduced, yes? So I'm going to put here OA. Okay? While I'm doing that, I'm going to say, okay, well, if it's being reduced, how much is it reduced? I would say that chromium gains 6 plus to 3 plus has to gain 3 electrons per chromium. For each chromium atom that I have, I'm gaining 3, yes? Okay, because we're just focusing on one atom to one atom basically, and that's our oxidation numbers. In total, look, how many chromiums do I have here? 2. So, in total, I'm going to put down here gains 6 electrons. I'm not going to take this one and times it by 2, of course, because I have 2 chromiums there. Okay? I don't care about the right side. The first thing I guess I should have mentioned is this. The only thing I care about the right side for right now is this. 6 plus to 3 plus. Each one gains 3. I don't care about that side anymore. I see each one gains 3. I have 2 here, so that's a total of gaining 6. Okay? What's the other one here that I need to worry about? What's my RA? Specifically, it's what? C, yes? This is my RA. Each C goes from a 2 minus to a 0. So I would say, well, this one is losing 2 electrons per carbon. Okay? Each carbon is going from a minus 2 to a 0. So it is going up. Minus 2 to 0, it's going up. Means it's being oxidized, therefore it's my reducing agent. Okay? Going up by 2s. I have 2 carbons, so this here loses 4 electrons altogether. There's 2 carbons right there. Okay? Yes. Okay. Those are the first most important steps. After that, it's not too bad. So, at this point, you are now at your, well, when you think back to what we've done, we're actually now at our reduction half-reaction and our oxidation half-reaction. We haven't written those out in a big long line, but I know that this one gains 6, so loses 4. Take a picture at reduction half-reaction with 6 electrons on the left-hand side. Picture an oxidation half-reaction with 4 on that side. How are we going to balance those out? Well, it's called multiple 6 and 4, like you would have done before. Well, so I'm going to take this one and times it by 2. And I'm going to take this one and times it by 3. Okay? And that's what you're going to see when you correct these. You're going to see exactly what you see up there. Okay? For all this stuff. Okay? So, I've gained 12 altogether here. I've lost 12 altogether. So basically, what we're saying is the coefficients for this one is a 2 multiplied by 2. This one here is 8. And then here's the deal. So we know those 2 numbers there. The rest of it is all based on those 2 numbers. Okay? That's the oxidation number part kind of thing, the gain loss kind of thing. You cannot change those numbers once you write them down. Okay? Once you put a 2 there and a 3 there, those are guaranteed. You don't change them ever. You can't go back and scratch it out and put another number there. It's not going to happen. The only time that would happen is if you messed it up from. that's a 2, that's a 3. The rest of this is based on kind of inspection. So don't worry, but just like kind of like before, what's kind of the main stuff going on here? Do we need to worry about oxygens and hydrogens first? No, probably not. Right? We need to worry about chromium, for example. How many chromiums I got here? 4. So I'm going to put a 4 here. Once you put that there, it stays there. Okay? That's the important part. You can't go back and change it. Okay? How many carbons do I have here? 6. Don't forget I got 2 right here. That's actually a 3. Actually. That 2 in that compound. Carbon. Those numbers, done. You have to balance the rest. Now you should probably, you think back to acidic or basic conditions. By the way, this is under acidic conditions, not if there's an H plus, right? So this is actually one of the ones that we would say kind of match up with acidic conditions. How did you guys balance that? You guys added waters? We have waters, we just don't know how many of the waters we have. We're going to do that first, and then you would add hydrogen to balance that out. So that's exactly what we're going to do. Let's see, 14 O's. Remember, this number is locked in here. 14 and another 3 is 17. Yes? That's locked in. I can't change those, so I know I have 17 over here. Over here, I have 6. So that has to be in front. Okay? 6 and 11 is 17 O's. And now that I know all that, I'm only missing 1. Okay? 1 number, whatever that happens to be. No hydrogens there. Okay, on this side here, by the way, I have actually 6 hydrogens times 3 is 18 hydrogens here. Here I have what? 4 and 3 is 12. And I just added those 11, so that's 1. Yeah. So on the right side I got 34. On the left side I got 18. Okay. So I need another 16. Balance that out. Okay. What do you think? Wait for the next one. That was the easy one. Yeah. Okay? That's okay. We'll work together. It's fine. What we'll do. Relax. Okay? We get 6 out of 6 is more good. Okay? How do you check these? Well, you add up, you check the atoms. Yeah. We already did that kind of, right? I mean, that's kind of what we just did. We check the atoms. I mean, if you really want to go back and double check them, you can. But remember, we kind of went step by step, balancing those atoms. You could check charges in. Listen, 4 minus, 16 positive. That's neutral. So what is that? 12 positive. And then here you got 12 positive. Good. Okay, so it's probably pretty good. But there's 2 ways to check things. There's atoms, ions kind of thing, and there's charges, right? So those are the 2 ways you're going to check them. Okay? Is there any questions so far? Now, the important thing is, of course, once again, just kind of go through this. You need to identify OA and RA. Sure. Okay, check. Most of us can probably do that. You need to decide how many electrons are being gained or lost, and multiply it by the number over here if in case there happens to be more than 1. Okay, you can always multiply it. Sometimes it's only going to be 1. Okay. Once you decide how many electrons are gained or lost in this step right here, I don't care about the products anymore. Okay. Don't worry about the products. You need to focus on the left side only, saying, okay, I gained 3 electrons per chromium. I have 2. So that's actually, I'm going to gain 6. Okay? And this one's going to lose 2 per carbon, and there happens to be 2 right there, so times 2. In other words, total loss 4. Okay? And then you're going to balance those 2 out. Put those numbers up there, balance the rest based on good old-fashioned chemistry, balancing chemical equations. Okay? Don't start with oxygens or hydrogens. Start with other things that are different, right? Iodines, Let's write out the equation for this one here. Let's balance some stuff here, guys. Okay, so here's your oxidation numbers. Okay. Now, sometimes we get a little confused here, but let's start with the I first, I think, maybe. I, you can tell here, I is going from a 1 minus to a 0. So 1 minus is here. So I can move the line this way, up or down. Minus 1 going up to 0. So is that being reduced or oxidized? Oxidized. Going up in numbers. So it's being oxidized. So this is a reducing agent. Okay. And while I'm on there, I might as well talk about how many I'm basically doing here. Being oxidized, so we're losing. Well, look, 1 minus is 0. Loses 1 electron per iodine. Loses 1 electron per ion. Right? So listen, this is important. How many I's do I have here? 1. Don't care about that side. Just this, right? Remember, I told you, the only thing you're using that left side to the right side, reactants and products, how many electrons am I losing? Losing 1. Per this. So that's it. This is loses 1 electron. Okay? Because there's only 1 on the left side. You might say, okay, look, guys, that's going from a -1 to a 0. Obviously, that's part of my reduction or redox reaction, right? In this case, that's the oxidation half-reaction. Well, where's that electron? If that electron's being lost, where's it being lost to? So students look at this and say, yeah, to -2, that's a -2 there as well. This hydrogen's a 1 plus 1 plus. This, though, yes, this one, you might say, well, which one do I use? Well, which one goes up or down? Because obviously, if I'm losing electrons, something's got to gain them. It's obviously not this one. It's this one. So this is my OA here, obviously, because it's going from a 0 to a 2 minus. It's going down. 0 to 2 minus. It's going down. It's being reduced. So it's my OA. In fact, in this case here, this would gains 0 to 2 minus, gains 2 electrons per oxygen, right? Yes? 0 to -2 per oxygen, and I have 2 of them here. So in total, gains 4 electrons. Okay? That one I do multiply by 2 because there's 2 of them on the left side. Once again, I don't care about the right side anymore. Okay? That's where you got to start. That might be the hard part. Okay, but this one's a little bit trickier. But that's pretty much, you got to do those first steps, always. Okay? Now, I say this one's gaining 4, this one's losing 4. Hey, this is the easy part. Okay? But this one's gaining 4, I got to lose 4, right? So I'm going to take this times 4, and this one has to be times 1. Lowest common multiple of 4 and 1. Okay? That's the easy part. Then I say, okay, this is times 1. I need to put a 1 here. That's times 4. I need to put a 4 there. Those numbers will not change. Okay? Yeah. To put it there so I know that that is done. That is done being balanced. Okay? You always put the numbers there. That way you know it's been done and it's taken care of. Okay? Because if I don't, I might start going here. And then down the road, I might come back to here and decide I want to change it. But if I change this number now, that's not the case anymore. The losing and the gaining is not the same. So that's why I put the numbers there to make sure it holds it, so I know that that's done. The rest is inspection, and you might say, okay, I got 102 here, and you might be tempted to do the O's first, and I would say don't do that. Okay, even though I know this one, we know it's 1 here. I get that. But there's also some over here, and then there's some over there. That might get a little crazy. Do the ones that you obviously know first. Like 4 I's, I can do that. That's 2 I's. Okay? 2I2, sorry. Now, that's good so far. Now you don't have a choice. You're going to have to balance O's and hydrogens. And I don't care which way you do it here. But look. Okay, so you might say, let's balance O's. So here's 2. There's 1 there. So maybe that's 3 on this side. Maybe I put a 3 here, over here. But then I got 3 H's, and that doesn't match up with those H's there. Okay? So you got to be a little bit careful here because it's not this to this. It's this and this to that, right? So it gets a little confusing. So that might not be the best idea. Well, let's balance, what did I say? That was O's. Let's try and balance H's. Let's see, 2 H's there. Maybe I need to put a 2 here, and that's 2 O's there, and that's 2 O's there, but that doesn't balance either. Okay? So what are the 2 ways you balance equations? What are the 2 ways you can balance equations? When you hand in your quiz, you check it. Do it by the charges, perhaps. Atoms. That's what we're trying to do. We're trying to balance it based on atoms, right? It's not working out so well. I've done 2 examples, and they're both not right. Okay? That's kind of hard to tell. And remember, you might say, well, yeah, maybe I'll put a 3 halves or I'll put a 1 1/2. You can do that. However, you can't change these, though, still, right? These are locked in. So based on the 3 numbers that I have there, the 1, 4, and 2, we need to come up with the rest of this balancing. And the 2 ways you balance stuff is atoms, which we're trying to do, or charges, which we can do. Because look, this will always happen in case you run into something like this. Look, this is locked in. That's a 0. This is locked in. That's a 4 minus. Yes? 4 minus. This isn't, but that's a 0. So I don't care what number I put right here. It's still going to be a 4 minus on this side, yes? No matter what. Well, look, that's a 0. What number do I got to put here? 4, because I want a 4 minus on that side. How else am I going to get the left side to equal the right side if I don't put a 4 there, right? So once again, 0, right? This is 0. This is 0. I already told you that that's a 4 minus because that's the first number we put down. Well, if this is a 0 here, and this is a -1 charge out here, I got to put a 4 there because the left side has to equal the right side. There's no other way that's going to happen, right? So now that I've put that there, does that help me? Oh, sure it does. Look, I got 2 O's here. I got 4 O's there. Let's put a 2 there. 2 O's, 2 O's, 4 O's, 4 O's. Look, 4 hydrogens, 4 hydrogens. Good. Okay? All good. All right? That one is, you know, a little bit more tricky, but it starts out as the exact same stuff to start with, right? How much does this one gain? How much does this one lose? Et cetera, et cetera. Okay? Questions, anyone? Now, I don't know if you're going to have to worry about the charge thing for your homework, what I give you today, but perhaps towards the end of the assignment, yes. I'm not going to give you all the questions today. But, any questions before we move on here? Questions? Yeah. No. Questions? Okay. So, the next one here is this one here. And we are not going to do this today because you'll notice, first of all, you'll see that it says in acidic conditions. So do you see any acid up there? No. So we may have to add some stuff in. Maybe this equation is not quite complete. Maybe we're missing a few things. And I will tell you this right now, that this one in fact involves fractions. So that is more suited for a Friday kind of thing. So we're going to stop for Friday, because Friday, fractions, friends, all start with FR. Huh? Think about it. So tomorrow, you should stick around. Come back tomorrow, because I'm going to blow your mind again. And we'll do fractions Friday. Friday fractions, friends. Fun day. The 4 F's, okay? All right, so we'll do that tomorrow, but I'm going to give you guys a few questions here to practice.